start with wave speed itself. So things we know about the wave speed. We know that it is dependent on the medium. The closer the atoms are, the quicker it can pass through it. And finally, the speed of a wave is always the product of its frequency times its wavelength. Let's take a closer look at that. Velocity, or the wave speed, is equal to the frequency times the wavelength. The velocity is equal to the frequency times the wavelength. In the earlier video, I mentioned to you that lambda, this is lambda is what represents wavelength. So anytime you see that lambda symbol, that's going to be wavelength, okay? All right, so when we're measuring velocity, since the very, very first day of physics when we started talking about velocity, because it was one of the first things we ever did, we learned that the units of velocity is always meters divided by seconds. So this unit is always going to be ms. All right, frequency. Frequency is measured in hertz, and the symbol for that is Hc. Wavelength is a distance. The lambda is a distance, and in physics, 9 times out of 10, we measure any type of distance with meters. So we have meters per second, we have hertz, and then we have meters. Those of you that need to use triangles like me, this is very easy to put into a triangle. Velocity is the product of frequency times wavelength. All right, so when we're talking about frequency, there's one more thing that we need to understand about frequency. In order to find frequency, we have another equation that we can use. So since wavelength is the distance between two consecutive crests or troughs, the frequency then would be the number of crests that pass a point every second. So we're looking at something in seconds, which means you're going to take the inverse of it. So for example, if I'm given a time in one of the questions, then to figure out the frequency, I would take whatever time they give me and put it under the number 1. So pretty much it turns out to be 1 divided by whatever time they give me, and that's going to give me my hertz. And the time will always be in seconds. But use this in order to figure out your hertz if you're given a time, okay? It's really simple. You just divide whatever number you're given into the number 1. Michael and Jared are fishing off the pier at Port Aransas. Michael notices that the ocean waves are 7.75 meters long and that one passes by every 2.55 seconds. What is the speed of the waves? So what do we know we got? Right here, we have a wavelength. So that means that this is 7.75 meters. We're given a time, which means we're going to figure out our frequency. So from the one before, remember frequency, I'm going to put this up here, okay? Frequency is equal to 1 over whatever the time is, so 1 divided by 2.55. And this is how we're going to find our hertz. So 1 divided by 2.55 is going to equal 0.392. 0.392 hertz. So we used this to find that, okay? And then finally it says, what is the speed of the waves? So what we're looking for is the velocity. Those of you that need to use a triangle, let's plug those in. So this is what you were looking for. The frequency is 0.392. And then our wavelength, our lambda, is 7.75. Okay, so you got the triangle filled out, and that means that we're actually going to be multiplying frequency times lambda. So this is the way the equation would be set up. v is equal to f lambda. That's like our original equation. And when you multiply all that out, you end up with a velocity of 3.04 meters per second. Okay, if you have a question on this at this time, you need to go ask your teacher to help clarify this. This is the one equation we're going to be working with in this module, so you need to make sure you understand it pretty well.